Hi, welcome to the Open Compute Project podcast. My name is Rob Coyle. I'm here with Jean-Marc Denis from Submer. Jean-Marc, thank you for joining me.
It's a pleasure, Rob, to be with you today. I'm very happy to be with the OCP community today.
Excellent. And a lot of people within the OCP community are aware of Submer because Submer has been a participant, a well-invested participant in the Open Compute project for a long time. But if you would, for those who don't know, could you share a little bit about Submer and what Submer is up to today, and then your role at Submer?
Okay, of course, let me start with Submer. Submer is a European company that has been created 11 years ago in Barcelona, Spain, in a garage. It's been a garage company at the start, focusing on immersive cooling. So 10 years ago, it was extremely innovative, and now it's becoming mainstream, which is something we're going to talk about, I guess. And I joined the company 6 months ago, last November, to run the product organization as Chief Product Officer. And my background is in high-performance computing, known as HPC. Almost 40 years. I have designed big supercomputers. I created the Build HPC, organization from zero, becoming number 4 at the worldwide level. I also created the European Processor Initiative program. I have been chairman of this initiative. I also launched a company designing microprocessors. I have taught in the past. I've been a teacher in a university for some time, teaching supercomputer architecture and microprocessor architecture. So with my background, I thought that last November, it was the right time to join Submer because we have a strong believing that first, immersive cooling is an incredible technology for the future. And when it's going to be combined with other cooling technologies not for the next gen, but for the next gen cooling technologies, that will be something totally incredible. So
Very
I wanted
exciting.
to contribute to that.
Well, and it sounds like with your background in education, efficiency, and innovation, you are very much at home at Submer. And then I also want to welcome you and say that you're very much home here at OCP as well.
Oh, yes. On OCP, by the way, a word about OCP. During long, OCP was something of a strange animal, I would say,
Sure.
for many people. And when we see the evolution of OCP that is becoming dominant on the market as a form factor, and with the sharing of lots of technologies between people, that is a very, very, very good move of the industry. I love very much open source, open technology, open something, open-minded. I worked a lot with universities and research labs, so this is a culture.
Mm-hmm.
And I believe that with the evolution of the market, where the hyperscalers, which are the top of the food chain, driving the specifications for the future, OCP will become soon the dominant form factor for all servers and technology vendors. And we believe very much in OCP. At Submer, we've been a contributor to OCP, especially in immersive cooling, almost forever.
Yeah.
We are part of the work group working on that. So, yeah, we are committed. And I guess for the people who are familiar with OCP, they know Submer and they know how committed we are.
Oh, yeah, very much so. Well, let's dive into it a little bit on how you see the future progressing. Historically, the industry spent really focused on efficiency, just raw compute performance. What makes the efficiency just even more important today?
Talking about efficiency, it's a very complex question. Yeah, coming from the HPC world, the big question has been always about producing more compute with the same power consumption envelope or even less than before. Maybe I'm a bit old, I'm 60, so I've been educated in a world where we had to save anything, anytime, energy, equipment, programming, implementing the same algorithm with less source code. It was the kind of problems we had in the past. This is not the case anymore. In the AI world where we are today, AI is dominating. So there is no discussion. When we talk about the evolution of IT today, we talk about the evolution of AI technology, an AI ecosystem. Efficiency is reduced, I would say, to some very simple parameters. It's about token, which is the fundamental metric for AI. It's about token per watt, token per dollar. But when you consider that the budget, the dollars, is something with almost no limit today,
Yes.
power is, I wouldn't say with no limit, but the limit is so high in the sky that, okay, for normal people, this is absolutely not a criteria. Producing more token per watt or more token per dollar is something that makes sense. And for that, we believe that cooling technology is a key contributor. And
Yeah, it
I
makes
guess
sense.
we'll
If
talk
our
about that.
limitation is power, that's what we measure to, right? If money is not seemingly the limitation, but power maybe is, it seems to make sense to measure to that. But today, the issue isn't that I don't want to buy that power necessarily. I mean, that's certainly part of the equation, but we're seeing power constraints where it might not even be available. How does
Yeah.
that show up in practice today, as opposed to we're making a calculation in your example of efficiency? What happens to the boots on the ground? But bring it to reality to us to compare a 1.3 PUE to a 1.02 PUE, and how does that show up in the field?
That's a question that is very interesting because it's a question of scale. Let's consider the very, very big whales, the 1 gigawatt campus. If you consider again 1 gigawatt campus of IT equipment, if your PUE is 1.3, it means you need 300 megawatts to cool your IT equipment. It's big.
That's
It's
an
very
entire data center 18 months ago.
it's it's crazy. Maybe it's a full city you cannot you cannot run.
Interesting.
300 megawatt is giant. And if you consider something at the edge, and we'll talk about AI continuum later, I think, because this is something super important to me. Uh, at the edge, even if you consider super small AI equipment or AI data center, a few kilowatt to a few hundreds of kilowatts, you are limited. You are limited by the building, you are limited by the city where you are installed, in the block where you are installed, and you are limited as well by the acceptance by the local community. And the people start thinking that, hey guys, I need to have some electricity for my house, for my fridge, for my air conditioning.
Right.
So at some point, the less electricity you need for your data center, this is more electricity for the people.
And I suspect that there won't be too many permits for on-site generation in a
Yeah,
metropolitan area.
yeah. This is true, and we see some kind of pushback in the US, in many states, in many
Sure.
local communities against the installation of giant data centers. Um, and to make a footnote about that, very often the pushback is not about the electricity; it's about water usage.
Hmm.
And on that consideration, the technologies we have developed over time with immersive cooling doesn't need water, meaning that for big data center and for the edge, and at the edge this is even more important, if you don't use water at all, the integration in the local environment, again in a building, in a cabinet or something like that, super low scale, is super easy to do. And not using water means this is more water for the local communities, for the people, for the farmers. So that is a very, very important point of consideration for the future.
Yeah, it sounds like. It's very interesting to think about maybe where the conversation is around very large data centers and your point to scale and how important that is. But uh, the applicability or the acceptance of data centers as they get closer to the edge
Yeah.
is a big one. Can you bring us to a conversation potentially between those who are specifying AI infrastructure, right? The technical teams and the business team when they're making these investments in this space. How does the
Yeah.
conversation go when, historically, if they were to, pick let's say a predominant legacy solution with uh, cooling that uses liquid and with an overhead of 30% for cooling power. I'm sorry, I misspoke. When I uses legacy uses water as a cooling solution, with this 30% overhead for cooling, how does that shift if we're looking at a solution that is leveraging a technology like immersion?
So in the world of data center, again, to talking in first place about the core data center, you need to redesign your data centers as opposed to transforming an existing data center. When you transform an existing data center, let's say the marketing name for that is brownfield.
Mhm.
When you create a new data center, the name is greenfield. So greenfield is easy. You find a place, you connect electricity, you find some water if you need some water, and you do whatever you want. And then you have the question of acceptance by the local community and by the states and by the federal level in the US and countries like that. So anyway, it is a very important point of consideration. And the building license could take years to be in place. And that could be, let's say, a stronger way. The legal aspect could be a very, let's say, elegant solution for the states and the local community to refuse the installation, not saying no.
Interesting.
Brownfield is more expensive than greenfield in terms of refurbishing because you need to refurbish, so it takes some time. It's expensive, but the building permit is already in place, meaning that it's easier to do in terms of, let's say, project plan, in terms of duration of the project. But it drives to the next point in terms of investment, because everything starts with investment.
Sure.
Um, Investors start having a strong concern about the monetization, the return on their investment.
Yep.
So they start asking the people building the AI solution, let me use simple words, to show the money. Very simple.
Yeah.
And uh, the question of monetization drives to the question of where is the money?
Right.
It's not the customer market, or very few. If you look at a company like OpenAI, they are dominant on the customer market. But this is
Sure.
not where they make money. They make money with enterprise, on business to business, B2B, meaning that the money is, as usual, at the enterprise level. And there is a strong money and profit for AI at the edge, for real-time answers, for the automation of a factory, for automated cars, autonomous cars, for smart cities, for video protection, for cybersecurity, for that kind of stuff. Meaning that if you have a solution where the production of the token answering to a request, say from a factory, is with a super fast answer, then the implementation in the factory of the evolution of the production lane or repairing something, at the end for the enterprise running the factory, is saving time, is saving money. So this is a good way for them to take advantage of AI, so they are ready to pay the more money per token. So the question is about having real-time AI at the edge, close to the place where the data is produced, the edge level. And for that, you need to have super simple solutions, something super reliable, with super low power consumption, meaning that the PUE we discussed about, the power consumption for cooling your IT equipment should be as reduced as possible. On this aspect, immersive cooling is by far the best solution for different reasons. First, the PUE is super low, 1.02, 1.03 with the technologies we have developed. Second point, no water usage. If you are indoor, that's crucial.
Sure.
And for a factory or any people running an edge data center, this is also a good way to get the acceptance by the local community. Third point, with immersive cooling, and this is coming by definition with immersive cooling because you use fluids, the thermal latency of a fluid is just great, much better than in the air, which is a gas. Meaning that with a reduced, let's say, with a strong, big thermal latency, you reduce the thermal stress on your IT equipment. As a direct consequence, the failure rate of your IT equipment is reduced. As a direct consequence of that, the maintenance is reduced. And you can operate longer with no failure your edge data center. This is something like install and forget.
That's fascinating because the historic objection to immersion is usually around maintenance because they're making a comparison to their existing air cooled environment. But if we shift the conversation a bit to your example in an edge application where you really think this is where the money is, um, it's kind of a different story, right? Now we have to, at an edge application, I have a technician that's worried about the entire envelope of the facility itself, be it
Yeah,
a module or in a small region.
yeah, you're right.
Speak
You're right.
speak to those who object to immersion because immersion's more difficult from a maintenance perspective.
It's been perceived historically as more difficult. It has never been true, but the perception, the psychological aspect, because of fluid, has been there in the mind of every data center manager. The reality is different. The point of comparison has been always air-cooled IT equipment. Now you have, if you consider three cooling technologies, air, direct to chip with cold plates, pipes, and stuff like that, and immersive cooling. If you look at the evolution of the AI equipment with GPUs and the AI devices burning electricity just like hell. Sorry, it's simple words, but this is what the people are telling. So you need to have super sophisticated direct-to-chip solutions, super complex pipes, heat exchangers, cold plates. It's super complex. And if you look at the last, for instance, NVIDIA servers, their direct-to-chip cooling solution is an amazing piece of engineering, but it's super complex, meaning the maintenance is very, very, very complex.
Mm.
The maintenance operator has to be trained. It has to use specific tooling for that. And the cost of the repairing units is very high. So when you compare to air, now let's consider immersive cooling. Immersive cooling is a standard air-cooled server where you just remove the fans, you qualify for immersive cooling with some different coolants and fluid, and that's it. Meaning that in operation, you extract from your tank your server. It's a classical air-cooled server without the fans. Then you wait some time, some minutes, not more, for having all the drops of liquids returning to the tank. Then you change your chip, you change your memory DIMM, your SSD, just like an air-cooled server. No sophistication, no complex training on your operators, no complex tooling, and you reinstall in the tank. So people start considering that when they compare immersive cooling with direct-to-chip, immersive cooling is better in terms of maintenance. Less equipment, less complexity, meaning that ultimately this is lower cost of operation. So immersive cooling is getting traction because you've got less maintenance, and when you need to maintain, it's easy.
Do you think that it's historically, when we just think, and I'm thinking a bit from a hyperscaler's perspective, even though our conversation is really around the edge, and I want to stay there at the edge, is that the discussion has always been cooling as a bit of an afterthought. And our focus has really been in response to the chip itself. Really, the response is to the silicon. We're not changing away from air cooling because of a limitation in the network or in energy storage. It is really due to the silicon. Why is that not the right approach? And how does that play out when we look at edge deployments?
Yeah. Again, I'm coming from a world where in first place, you choose your IT equipment. And then when you had to build a new data center, you were thinking about by building a big data center, having electricity. And then you were thinking about the design of your cooling equipment. It was 3 different stages, 3 different independent steps in your
Yeah.
process. And the duration of the whole process could be 2 to 2.5 years, 3 years, quite long. But it was not a problem at all. Now, the investors are asking for super fast return on investment. So time to first token should be a few quarters. Typically, today, the expectation is from land to first token, 6 months, whatever the scale. 50 megawatt, 100 megawatt, you need to build something in 6 months. There is absolutely no complexity for doing that. You go with modularity in the design of your data center, meaning that you need to combine the 3 stages I mentioned, the choice of the IT equipment for the usage you have, plus the choice of the, let's say, the shell, the data center itself, the
Okay.
design of the data center, and the design of the cooling solution with the choice of the IT equipment, everything at once. It's a full co-design approach. And again, this is one of the super strong advantage of OCP because it's standardized. Whatever the choice of your supplier, they all follow the same, let's say, form factors and rules. So in terms of co-design, it simplifies the complexity. It dramatically simplifies the complexity. And at Submer, we have anticipated the trend, and now we are working with data center, let's say, builders, design and build people, plus the end users. And we talk about the usage. Is it for training? Is it for inference? Is it core data center? Is it at the edge? What's the usage model? And depending on that, we co-design different solutions. And for the edge, we have turnkey data centers solutions, combining everything, kind of nano data center, kind of micro data center or mini data centers from a few kilowatt to 1 or 2 megawatts. Turnkey solutions, you just choose your IT equipment and it's done. All of that with all the efficiency that comes with immersive cooling. And for the core data centers, we work with operators with modular design, and we know how to install a complete AI data center from land to first token in 6 months for the scale we already have discussed from a few megawatt, a few tens of megawatts to, let's say, 100 or more megawatts. Not a problem, just a question of co-design.
Yeah, that's right at home at OCP. You're very right. It's also very interesting to hear that that's your approach at Submer, and then it also sounds like that's how it shows up in your products and your solutions is through this co-design philosophy. We're going to talk more in the future about our AI computing continuum. So I'm excited to potentially have you back where we get to talk about that because I think this is key to this. My next question, or my final question is, as inference scales up, what is the infrastructure assumption that most organizations are getting wrong? because a lot of the focus is on training. It's on the biggest. That's what's making the headlines. The biggest scale, and from your point earlier, the big scale and the issues with those. But what are we missing on? I would say really this next wave in the AI era, which is around inference.
That's a very interesting question. It's a complex one. I would say it's a kind, we're entering the Cambrian era for inference, meaning you are starting to find on the market an incredible diversity of AI engines, not only the very standard NVIDIA GPUs.
Sure.
You have tons of different competitors at any scale, any usage, uh, image recognition, well, anything you can think about in terms of usage. You start finding on the market startups or even big companies uh, developing specific solutions. I mean, IT. So the big question is about offering data center cooling solutions. So everything you need to make your IT equipment working well with strong stability and reliability. So that kind of, let's say, envelope on companions for your IT equipment, flexible, easy to adapt, and offering always the same characteristics. Again, OCP is helping a lot.
Sure.
And having something super simple in terms of cooling solutions, where instead of adding complexity for cooling, you remove everything you can remove, bare to the minimum, just a fluid where you transfer the heat. This is the
From
best way to avoid complexity and to be able to be agile enough to address any need that will come in the future.
from an interface, this makes me think we're more back to the ease of air
Yeah.
when we go from that perspective compared to these
And
other
by the way,
solutions.
the air is a fluid. A gas is a fluid. A liquid is a fluid. That's the difference. Nothing else.
Very interesting. I think a great point to end on, Jean-Marc. In our last send off here, where can people find you? Obviously, submer.com, certainly for your solutions to reach out to you. Anything else you'd like to leave us with?
Yes, Submer.com is a very good entry point to know more about the solutions we are offering. And when I say solution, it's obviously the products, tanks, cooling solutions, but the modules and the global data center solutions we can also offer. Go to submer.com and you will find more.
Well, we look forward to hearing more from you and seeing you around the OCP community. Thank you so
Yes.
much for your time today.
It's been a pleasure, Rob, to be with you today. Thank you very much.